Hey everyone, I'm just getting myself organised here, but I think we are getting close to being ready to start. I'm making it 8:57 New Zealand time here, and we're due to kick off in just a couple of minutes, so we'll just wait for everything to settle down and for a few people to join us. In the meantime, feel free to comment either on Facebook or on YouTube, and I'm hoping, like anything, that our comments work just down below me here. It's supposed to be working, but we never really know how well that's going to work. So we're just kind of hanging around for a little bit and waiting to see if anyone is going to start commenting. We've got a few people joining us here, so we'll just hang fire for a couple of minutes and we'll be ready to get things going. I tell you what, just bear with me a minute. I'm just going to see if I can fiddle around. Oh no, here we go. We've got something happening on the Facebook comments. Hi Melanie, thank you very much for commenting. That shows me that the Facebook comments are working. Hopefully the YouTube live chat will kick in shortly as well. You guys who've been following us for a while know the drill. It's always a bit hard for me to see the comments, especially when I'm working by myself. And I think I still need to make them... I'll tell you what, I can sort of see the comments reasonably okay, but it's a bit harder to see the names. Leroy, kia ora, welcome. Kevin, good to see you again, Kevin. Thank you for joining in. Debbie, Wendy, nice to see you. Hey guys. Not sure why, the YouTube one, not sure what's going to go on there. Let's just see what happens. Okay, lots of people coming in. I'll try my best to keep an eye on the comments, but what I might do is once we start, I'll actually have another computer going in the background over there, and I might just go and check on the comments from time to time. Okay, it sounds like you guys can hear me. Someone let me know if you can't hear me okay. But I think with that, we might as well get things underway. So, good morning everyone. Good morning to everyone in New Zealand. Welcome to this, and a good evening to our UK viewers. I know we've got at least a few people joining from the UK and possibly from other parts of the world. Thanks for being part of what should be a historic occasion here, where we attempt to watch a robot land on Mars. It's not quite that simple, of course. We don't actually get to see the robot land on Mars in real time. We'll talk more about what we can expect to see shortly. If you just bear with me one quick sec, I'm just going to see if I can figure out what's happening with the YouTube live chat, and to do that, the screen just goes blank for a moment, so apologies for that. I'm going to see if I can reload the YouTube chat and see if we can get that working. If not, I will just give up on it and we will carry on. Right, that's all I'm going to do. I'm going to officially give up on that and hope it happens, but if it doesn't, too bad. So, what's happening today? In a bit less than 1 hour from now, we should be tuning in for Touchdown. Now, what's going to happen is we'll start off. I'm planning to just give a little bit of an introductory overview about what we're going to see, what we can expect, what's happening today, why we care about all of this. But we will cut over to NASA's commentary, and they do a pretty good coverage, really, or very good. Not pretty good, it's very good. So we will cut over to their coverage, and as long as we are happy with that, we will stick with them for most of the important parts. So in the meantime, a couple of little bits of housekeeping. First of all, the link down here, spacecentre.nz live, that page has got a few important links. In particular, if we lose this feed, if anything goes wrong, you can go there and go to JPL's YouTube channel, NASA's Jet Propulsion Lab. They are streaming the whole thing. That's the feed that we are taking. So you can watch it directly from there if you prefer, or if we lose this feed, just go there. There's also a few links there with just background information about this and a couple of other interesting things. So feel free to go and check that out. look, I'm not going to bother about that other stuff. Let's just get on to what we're talking about today, Mars. So I should quickly point out that this is not the only mission that's arriving at Mars around this time. There are also 2 other spacecraft that have recently arrived at Mars. The United Arab Emirates have just had their orbiter arrive, Hope, which is orbiting Mars right now, and the Chinese have just had their orbiter arrive at Mars as well, and they are hoping to have a lander go and land on Mars. I believe it's in May, actually, so that one's a little bit further away. So there are 3 spacecraft that have just arrived at Mars and are all taking part in this exploration. This happens about once every 2 years. It's to do with the orbits of Earth and Mars. Around about every couple of years is the right time for everything to be done most efficiently. So that's why we're seeing 3 of them arrive at roughly the same time. So what I might do is just go over just a very quick little bit of history. I think we're actually going to skip most of the history, and we're just going to go back to the 1960s when we had our first flyby of a robotic space probe going past Mars. This is really, I think, where our modern understanding of Mars really started kicking in. This is when we got our first close-up views of the planet Mars and started figuring out what it was really all about. There's been a whole bunch since then. I think the next major one would have been the Vikings in the 1970s. These were the first successful landers on Mars. They weren't rovers, they just landed and stayed in the same spot. Their mission was in part to try and find any signs of life on Mars. Their results were ambiguous, shall we say. So yeah, they didn't really tell us that much. We've had a whole bunch since then. Here's just a few images of some of the other robots that we've had at Mars. There's been a whole lot. This list shows you all of the robotic missions that have been launched to Mars over the years. It's a long list. Unfortunately, if we take away all of the ones that have failed, you can see that's also a long list. It's hard getting to Mars. It's a difficult thing, and roughly 50% of them have failed. The good news is that if you look in the last column there, most of the more recent efforts have been successful. We're getting much better at this. And the last 3 down here, the ones that I've just mentioned actually, the United Arab Emirates one, I've got question marks. This is a few days old now. The Chinese one is actually, I think we'll call that a success so far at least. And today, Mars 2020, that we, hopefully by the end of today, I will take away both of those question marks. So that's where we are at now. This image shows you a sort of a family portrait of the successful missions that have been to Mars. Most of them are orbiters that just orbit around Mars, studying it from orbit, but there have also been a bunch of landers on Mars. So that's kind of just a very quick history of where we are at. What we are hoping to see today is this beauty. This is a CGI image, of course, just in case there's any confusion. It hasn't landed yet, and this is what we think that it will look like once it lands on Mars. It's pretty spectacular. So it's approaching Mars right now. And what's going to happen today is the entry, descent, and landing procedure. This is what it's all about. This is known as the 7 minutes of terror. This is when the spacecraft lands at Mars, and it's got to go through that whole sequence of landing. Let's just quickly go through that actually. So first of all, I'll just show you this exploded image of what is approaching Mars right now. So all of these things are together. This has just expanded it out to show the different components. From the top, that's the cruise stage. That's the part that just helps it to get all the way to Mars. The next one down is the back shell. Then we've got the descent stage, this one here. It's kind of like the jetpack with its rockets that does a big part of the landing. The actual rover itself is this bit here. That's the Perserverance rover. That's what we're really interested in. And then the bottom thing is the heat shield. So right now, they are all together, still approaching Mars up here, and that's what it looks like. So once it gets to Mars, this is the important part. Now remember, this whole process that we are talking about, the rover has to do it all by itself, completely autonomously. Because it's about 11 or 12 light minutes away from us, that means that any kind of radio signal or anything else is going to take, I think it's about 11 minutes and 20 seconds to get from Mars to Earth, or vice versa. That means that we can't control it from Earth. The whole process takes 7 minutes. And it would take longer than that to get a signal there. So the whole thing is done by the spacecraft and the rover itself without any input. In fact, from now, the whole thing is just going to be doing it all by itself. So it approaches Mars, it hits the atmosphere, and we've got a whole sequence of things that need to happen. The heat shield, first of all, will help slow it down as it hits the upper atmosphere. So as you come down here, you can see it being slowed down somewhat. It starts to guide itself towards where it needs to be. Around about here, we deploy the parachute, which will slow it down a whole lot, but not enough. Mars has a very thin atmosphere. It's only about 1% as thick as Earth's atmosphere. So the parachute won't slow it down enough to land. At this point here, we lose the heat shield underneath it. And that means that the rover is actually exposed to the atmosphere, and that's where it can start using camera operations. So it will be able to see the ground, it'll be able to take photos, and it actually uses that to guide itself. It's got its own photos on board of where it's targeting, and it compares that to what it's seeing with its cameras, and uses that to guide itself to its intended landing spot. So we keep going along, it's using its radar lock here, and it starts its pretty advanced guiding technique down around about here. That's where we lose the back shell and the parachute, and at this point we've got the descent stage and the rover are still both together, and that's where we start the powered descent part. And so that's where the rockets will shoot out the bottom of the jetpack. And that's the last part, well, almost the last part. When we get down here, that's where we start the sky crane maneuver, where the descent stage at the top will lower the rover down onto the ground. And after about 7 minutes, hopefully we will be on the ground. This is what they call the 7 minutes of terror, because we've got no control. It's just all happening. Now, of course, there is a delay here. What we will be seeing and hearing and the data we're getting is going to be delayed by over 11 minutes. That means when we see the start of this sequence happening, so the rover hitting the upper atmosphere, it's actually already happened. One way or another, the rover will be on Mars. Ideally in one piece. That's what we're hoping for, but we just don't know. We just have to wait and hope. So it's quite incredible. It always blows my mind that the robot can do this whole thing all by itself. And there's a whole bunch of really awesome innovations with this landing. It's building on what they've learned in the past. It's quite similar in most ways to the Curiosity landing back in 2012, unbelievably. I can't believe it was that long ago. But anyway, so that's how all of that works. So I want to talk about where we are going to land. So we're landing on a place called Jezero Crater. Let's have a look at an image, a map of Mars, looking, basically a 2D representation of Mars. And this shows you the landing sites on Mars of a whole bunch of previous landings. But what I want to do is, I tell you what, let's just start just quickly. I'm going to go over to Stellarium, our planetarium app, and have a look at Mars from Earth. So this is actually, this is set up. I've just been using this. I've actually, just before we went live today, I was doing a session with a bunch of brownies in the UK, and hopefully we have got some of you guys. I know some of you were keen to stay on and watch this. It's getting a bit late for you there, but good on you for staying up and watching this. Now, what we are seeing here is actually what Mars looks like right now from the UK. If you look towards the southwest, you can see the moon, and you can see Mars just above the moon there. So you can go outside and look towards what is happening right now if you are in the UK. Now notice that Mars appears above the moon in the UK, but I'm going to come back to New Zealand, which is my default location. Now this is what New Zealand's sky looks like right now. It's daytime, so we can't see Mars. So what I'm going to do is I'm just going to go forward to nighttime tonight, and if we come around here, that is what Mars will look like tonight from New Zealand. Notice that Mars is actually below the moon. We are seeing it a little bit differently down here in New Zealand. And I'm going to flick over to our space simulator, Celestia, and see where things are. So this is what Earth looks like from out in space right now. And I want to see if we can find Mars. Can I see it? Uh-oh. I think, here we go. Sorry, I just lost control of my space simulator there for a moment. So what I want to do is I want to find Mars. I think if we, there it is over there. So hopefully if we select Mars and show it to you, that is what Mars looks like from Earth over there. Now, you can also see the moon. Hopefully you guys can see that there. If I flick between Mars and the moon, you can see that they are both quite close together. Now you'll see that in this view, Mars is above the moon. This is kind of because we're looking at it the right way up, the northern hemisphere view. So the view we saw before where Mars is above the moon, this is what it looks like. Kind of if you're on top of the Earth looking at it. But if you're down in New Zealand, where we are, of course, everything is upside down, and from here, Mars appears to be below the moon. That's why it looks different from different parts of the Earth. Okay, so that is Mars. We actually need to go and have a look at Mars because I want to show you where we are targeting and what we are looking at. I'm trying my best to keep an eye on the comments, but it's just not working. It's a little bit too small for my old eyes. Sorry about that. So what we should do is we should go all the way to Mars and have a look at where we are targeting. Let's go there. So this is what Mars looks like right now if you were approaching it. So Mars is a beautiful place. I don't know why some people think it's boring. It is it's a stunningly beautiful place. Lots of you will be familiar with some of the features on Mars. For example, the Hellas Basin down there. Most of the well-known features of Mars, I think, are actually around the nighttime side. You can see, looks like the North Pole up there, the South Pole. You can kind of see it down the bottom there. Around the nighttime we can't see much, but I'm going to cheat and I'm going to turn the lights up so we can see the nighttime of Mars a little bit better. And you may be able to recognize some of the well-known features. For example, in there, that is Olympus Mons, the largest volcano in the solar system. Some other big shield volcanoes around there. This is Valles Marineris, the biggest canyon system in the solar system. Those will be some of the well-known features of Mars. Let's reset our light. Where we are targeting today, where Perseverance is attempting to land, is in this area. That big dark area there is called Syrtis Major Planum. All that dark area is volcanic basalt, and we are targeting an area just around here, right in about there somewhere. It's one of these craters in here. And it is that crater. Sorry, the resolution gets a bit low here, but that's where we are targeting. It's called Jezero Crater, and it is in that part of Mars. So that's where the rover is targeting. So we come out from space, and we're going to go in there and hopefully land in somewhere around about here, more or less roughly. That is our landing ellipse, or the area that it is hoping to land in. So that's what it looks like from out in space. I'm going to show you an image here taken from, what was this one? This was from Mars Reconnaissance Orbiter. So this image was put together from data from the MRO, and this shows you exactly where we are hoping to land. This is a fascinating area. It's an area that we've actually been wanting to land on for a long time, but it's rather dangerous to land in. So previous landers have mostly gone for wide, flat areas with very few obstacles so that it's safer to land. But as they've been getting better and better at targeting smaller areas to land in, we can start going for some of these more difficult places to land in. So there's a lot of stuff going on here. This is actually, I'll show you another view. This is from the European Space Agency's Mars Express orbiter. So these are satellite images. And again, it's in this area here that we are targeting to land. And what's going on is we think that this whole crater area here billions of years ago actually looked like this. So this is a CGI image, and we believe that in Mars's ancient past, it was a lake. And so this is a really good place to be looking for signs of ancient life. And so you can see rivers coming into it here. And this is what we are looking for. That's about where we are going to be studying now. But in modern times, of course, it's all dried up. But you can still see the remains of this ancient riverbed coming in here. And what happens is, as it comes into this part of the lake, or what's now just a big crater, it spreads all the sediment and stuff that it's been carrying in this river out into this delta. So we have these deltas here on Earth. It's a common kind of geological feature. But this is a prime spot for looking at for signs of ancient life. All the sediment and everything else will be carried down that river and spread out in these beautifully, hopefully preserved areas in this crater. So that's why we want to go here and study it. It's all about searching for these signs of ancient life. So the rover itself, Perseverance, this is what it looks like. And it carries with it a bunch of scientific experiments and equipment, instruments, and each of them has a different job to do. The robotic arm is the bit that kind of sticks out here and can move around. That's got a whole bunch of stuff with it, including some spectrometers that can help figure out what things are made of, essentially. The cameras, of course, this is where it takes all its beautiful panoramic images and a whole bunch of other stuff. Let's see, the subsurface radar. This is a part that can use radar to look underground, to look at the subsurface makeup of Mars. A thing that I really like is MOXIE. This is an experiment that is going to attempt to take the Martian atmosphere, so it's going to suck in some of Mars's atmosphere and turn it into usable oxygen. So this is really just a technology demonstration. It's an experiment to see how easy is it to take the Mars atmosphere and turn it into oxygen that we could use for people to breathe, or you could use it as part of your your fuel system for rockets and things like that. So these are all the things that the rover is going to do. One of the really cool things that it's going to do is the rover actually has a little wee helicopter. We might have a closer look at that in a moment that goes with it. This is just a test. So that's one of the things it's going to do. It will also be attempting to take samples, and you can see these little containers here. These are sample containers in the CGI image, and the idea is that it's going to collect a whole bunch of these samples. I think what I might like to do is show you a couple of videos. This will show you how it's all come together. So first of all, here's just a few shots of the rover itself being put together. So this is in their clean room. You can see all the engineers and people working on this are very, very particular about keeping it clean. It's very important both for planetary protection. We don't want to contaminate Mars. We are also looking for signs of life, for tiny, tiny microbial signs of life. So it would be very unhelpful if the rover itself was covered in microbial life. So we want it to be essentially sterile. So that's what these guys are doing. They're putting it all together and trying to be very, very clean in the process. And you can see them testing out all the different parts of how it works. So this was them putting it together. Then last year, at just about the worst possible time, July 2020, a time we would all prefer to forget, this is when it was launched. So it launched on top of an Atlas V rocket about 6 or 7 months ago, and it is on its way to Mars there. So this is it launching into space, and then begins its cruise stage to head all the way to Mars. Now the important bit, the entry, descent and landing. This is a computer generated sequence of what's going to happen today. So this is the whole thing approaching Mars, and you saw the sequence before that we talked about. So it's just lost its cruise stage there. So the bit that helped it to get all the way to Mars, don't need that anymore. This is just the rover inside there, streaking through. It's hitting the upper atmosphere. You can see the heat shield there. It's getting very hot. This is helping it to slow down. This is inside. Everything's all starting to get a bit rattly in there, but it's still just room temperature inside. The heat shield is supposed to keep it really quite cool. So we then deploy the parachute, an enormous parachute, about 20 meters wide. It's coming cruising in. Oh, doesn't it look beautiful? Oh, it's awesome. Remember, this is just computer generated stuff. We won't actually get to see the stuff. Then it drops the heat shield and we can see the rover itself is now exposed and can see the ground itself. Then the rover and descent stage drop away, fires up its rockets. So this is the descent stage or the jetpack with the rover underneath, and that's slowing it down enough to come into the landing. The next big thing will be the sky crane maneuver, where the descent stage, the jetpack at the top, will lower the rover down on cables so that it can land on the ground. And that happens about 20 meters above the ground. So we're getting into that now. Here we go. This is the sky crane maneuver. It drops it right down to the ground. Then immediately we'll cut those cables and the descent stage goes and flies away and lands somewhere else, a safe distance away from the rover, and then we are all good to go. So what's going to happen today is, as this whole process is happening, we won't see any of this happening, almost certainly. There is a chance that we may get the odd image during this process. It will just be from one of the guidance cameras. It won't be anything special. And to be honest, I would be surprised if we even get that much. Really, what we're going to be seeing is NASA's mission control. So we're going to be watching the people as they get the data and stuff coming in. So we will be taking our cue from them about everything that's happening. And what will probably happen is that they'll have someone in mission control announcing what's going on at each step of the process. So they will be saying things like the parachutes have deployed. They'll be talking about the velocity, probably, how fast we're going, heat shield separation. So we're taking our cue from them. Now, although we can't see the actual stuff happening, I think there's really something in watching the people in mission control, watching the reaction on their faces, watching the tension. This is reality TV. This is real stuff. This is real tension. Remember that these people have been working on this mission for many years. They've devoted a large part of their career to making this work, and it all comes down to this 7 minutes of terror. If something goes wrong, then all their work over all of these last years is just gone out the window, and they probably won't get another chance to do it again. So it's tense stuff. It's pretty moving, actually, watching these guys in mission control. Now, if you're careful, sometimes you can actually get a few clues by watching the people around the mission control. You can sometimes you'll see someone who's maybe their part of the mission is coming up next, and they'll get the data in first, so they'll suddenly start getting excited and animated before you actually hear the announcement. So you can get a few clues there. Now, one complication in all of this, of course, is COVID. So normally mission control is packed full of people, but a lot of them are working from home. That's been a whole drama in itself. They've had to figure out ways to make all of this process happen without them all working together. So that makes it a little bit more tricky. I'm not actually sure how many people are going to be in mission control, but we're going to find out very soon when we cut over to their coverage. So I'm just going to close a couple of windows down over here and start thinking about getting ready for that, because probably before too far away, we are going to think about going over to NASA. We're only about half an hour away from touchdown. So remember, it's really all about this EDL, entry, descent, and landing sequence. We are waiting for each of these milestones and the magic word touchdown. That's what we are all waiting for. Touchdown confirmed will be the words that we are all listening for. When we see the first images from Mars is anyone's guess. It is quite possible that within a few minutes, or possibly even before then, we may see the first images, photos coming back from the rover. It's most likely to just be one photo, and it will almost certainly, if we do get one, it will just be from one of the navigation cameras, HazCam or something like that. It won't be much to look at. Okay, so don't get too excited. The good quality pictures will take at least hours probably to come back, and it won't be really over until sort of the days ahead that we start seeing some of the good stuff. Now, in terms of things like when's it going to start collecting samples, when's the helicopter going to fly, that kind of stuff, that's much later again. Now, before we do, let's see how our time's going. Let's have a look at a couple of other quick videos. I want to show you this video showing how the sample system works. So again, CGI, this is sped up a lot, by the way. So what's happening here is that the rover is taking a sample. So this is a core sample drill bit. It's a hollow drill bit. It drills down into something. But it's actually taking a sample of it, and it brings that sample back into the main body of the rover in a similar way to Curiosity rover. But the difference here is that at this point the rover is really only taking a couple of photos. It's measuring how much material it's got. That's what it's doing in this part here. It's doing a couple of quick preliminary looks at the sample, but the whole point is to save this sample and later on bring it back to Earth. So what it's doing here is it's actually storing it, and then later on it's going to dump it, and all of these samples will eventually be picked up by another rover and brought back to Earth, where we've got much better instruments and ability to study it more closely. So it just carries on, it keeps picking up a whole bunch of samples. It's got room for about 40 odd samples, and then at some point further down the track, it just kind of poops all of those samples out onto the ground and leaves them for some future rover to come and grab. So that's how the sampling system works. Let's also have a look at the helicopter. This is awesome. So it's called Ingenuity, this little wee helicopter here, and importantly, this is just a test. It's really not designed to actually support or be part of this mission. It's just a way to test powered flight. This will be the first powered flight on another planet. It's really, really cool. So it's got to be really light. Remember that the atmosphere of Mars is very thin, so it's not going to get much lift from those rotors, so it has to be very, very light. So the idea is that it can fly autonomously. It goes up and it will have a look around the surface of Mars. So in future, the idea is that one of these helicopters obviously can take better photos and things, but it can also work with a rover. It could get up high and have a look at the terrain around the place and help figure out which is the best place for the rover to go, so they can kind of work together. But at this stage, it's just doing a whole lot of testing. Now, the helicopter will have a camera of its own. It will be able to take some pictures. I'm not quite sure of the quality, but I expect it to be not incredible. It's mostly just to help it with its navigation and stuff. So I'm not too sure exactly what we can expect from this. It is really mostly about just trying to make something like this work on Mars. So I think those are all the main things that I wanted to talk about before we cross over to NASA, which we will do really quite soon. Let me just quickly whiz through my notes here, which I have completely ignored. So I think we covered pretty much all of what I wanted to talk about there. I think I mentioned the goals. Overall goals are to collect rock and sediment samples to bring back to Earth later on. I should point out that that's ages away, unfortunately. That part, the retrieval part of those samples won't be happening for at least 10 years. So that's a bit of a downer on the whole thing. But, you know, it takes time. Space is hard, and these things do take a long time. So I think that's probably all of that. I'm sorry I have not been able to keep an eye on those comments. I've realized that they are a little bit too small for me to see over here. So what I might do is I think we will get ready to cross over and see what is happening at Mission Control. I might just have to reload my Mars feed, and I will hand you over to NASA, and we will keep an eye on what's happening there. I probably won't really butt in much once we go over to NASA. I think we should just leave it to them. But I will be around after the landing once everything has settled down. We can come back and we can have some more of a chat. And hopefully I might, in the meantime, see if I can sort out a better way of looking at comments and stuff so I can actually have a chat to some of you guys. So with that, let's see if we can listen in.
It's very easy. We're human beings. We're not perfect. Mistakes can be made.
Okay.
We each count on each other.
I think we will cross over to NASA right now. I'm going to go and take care of a couple of other things. And so touchdown is a little less than 20 minutes away. Why don't we just do it like this for now? This is the NASA feed. I'll hand it over to you, over to them for now.
History have failed. And so it's that could happen today too. Even though we've had a nice, wonderful string of successes in the United States, it's still still a bit of a gamble that we have hoped that we have erred in the side of luck. And we've stacked the deck and loaded the dice to make this thing succeed. But if we do fail, if something bad happens today, I can tell you we're going to learn it. We'll have the data that tell us what happened. We'll know why. We'll figure it out. And if we are allowed, we will pick ourselves up and get us back on the horse. And if Congress and NASA allow, we will try again. As we always do, we will learn from our mistakes.
And what are the possible scenarios we could be looking at today?
Well, there's things like one of the key stressful elements for all of us is parachute inflation. But just even separating from the cruise stage is a pretty major event. Lots of devices have to work properly. Certainly, the heat shield separation, getting the descent engine started. There's no less than 16 rocket motors that have to work. 8 to control during entry, another 8 to control it during landing. I said it's a lot of stuff, and it all has to work. And guess what? We haven't done this before with this vehicle ever. This is its first attempt to actually land. We can't try this on Earth. We can't do. We don't have test pilots to try it out on this planet before the big show. So this vehicle is doing it for the first time. We've done the best testing we can do in bits and pieces, but you know, it's as best as we could do. But I think our team is up to it. This team is the best. It's a diverse, intelligent, amazing group of people. People from all over the world who worked on this, not just here in California, but all over NASA, contributors from aerospace, universities, countries around the world. It is just an incredible, remarkable engineering achievement, and I am just so proud of this team.
Thanks, Rob. Now, let's listen back into mission control.
Right, we're about 14 minutes from entry interface. The vehicle is currently preparing the heat rejection system that has kept the thermal system cool inside the air shell for about the last 6 months. This will allow the spacecraft to more easily cut the line in upcoming cruise stage separation, which is under 4 minutes now.
We have now enabled the Rover Pyro bus.
That's the pyrotechnic system that's
we are powering off the cruise stage devices.
And these are the things in the cruise stage that we no longer need. With the pyrotechnic system working, we can explode the devices.
The vehicle is preparing for the upcoming cruise stage separation in about 3 minutes 15 seconds by powering off all the devices on the cruise stage in order that they can be safe once the cruise stage is jettisoned.
Yeah, this cruise stage has been very reliable.
We are firing our first pyros to vent the HRS liquid and gas.
This has been the coolant that's kept their vehicle from getting too hot on the way to Mars. We have to vent it into space. And this is one of the first major events that take place as part of entry, descent, landing.
The HRS vent anchor is complete.
Yes.
We will see the next anchor in approximately 3 minutes.
Okay.
We are currently 12.5 minutes from entry interface. We are coming upon cruise stage separation in 2 minutes and 20 seconds.
What's happening now, Rob?
Okay, well, we're just waiting. The Rover is completely in charge. It's doing all the things we've taught it how to do. It's all built into the software. We've tested it over and over and over again. This team has spent 24 hours a day, 7 days a week, testing this thing for years. And so this is really the culmination of all that work. So this vehicle is getting ready to push that cruise stage away. Once it gets pushed away, the entry system with the rover inside, with the rover still in charge, is going to get ready to take the vehicle, turn it to the right orientation, and aim it to Mars, and prepare for entering the atmosphere. This won't be long. Be prepared for this event.
We're about 1.5 minutes from cruise stage separation. About 11 minutes, 20 seconds from entry interface.
Okay, so it's about 10 minutes from cruise stage separation till entering the top of the atmosphere. From then on and out, things happen
We are
fast.
switching to MFSK tones. Telemetry will have stopped.
Telecom is confirming that the spacecraft has switched to broadcasting tones. These tones are received directly from Perseverance, but have very limited information content. We won't receive real-time information until about 9-10 minutes from now, once the Mars Reconnaissance Orbiter starts relaying information from Perseverance. We are under a minute from cruise stage separation, about 10.5 minutes from entry interface.
It's getting exciting. I have to admit, I am quite anxious, but very hopeful that this machine is going to do what we asked
We
it
are
to
seeing
do.
the heartbeat tones.
Okay.
I'm just going to quickly button here. I'm going to go back to NASA very shortly, and I'm going to go full screen with it, so you won't be able to see me anymore. I've just tried to have a look at our comments, and I'm having a nightmare. Facebook is telling me that there are 42 comments there, but just won't show me them. I'm clicking on comments no matter how I try. I swear Facebook is a nightmare to deal with when you are live streaming. But I have seen I can see 5 of them. Facebook won't show me more than 5 of the comments, no matter how I try and do it. YouTube, I can see some of you guys on there. So I just wanted to say hi to everyone. I can see some of your comments. I'll try and get back to you after this, but I think now it's important that we cut back to NASA for what's going on here. So cheers.
We're off on a good start.
In about 1 minute, Perseverance's landing software will wake up and begin the final preparations for entry. The first action it will do is to fire warm-up pulses with its entry thrusters. These pulses ensure that the spacecraft gets the thrust that it wants during entry interface. We're about 9 minutes from entry interface.
Okay, so now the vehicle's on its own. It's turning itself into the direction of facing the heat shield toward Mars, and will eventually hitting the top of the atmosphere. We're not far away. This is going to go very quickly from here on out.
That's confirmation that we got shadowed by the cruise stage as it passed through our beam to the Earth.
Telecom indicated actually that we could see a signal that the cruise stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream indicating the cruise stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. Warm-up pulses have begun. At this point, the spacecraft is trying to stop its spin from the cruise 2 revolutions per minute down to 0, and then will turn to its desired orientation from entry. It will separate the 2 balance masses that has kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry attitude. We're about 7.5 minutes from entry interface.
Okay, the vehicle is pointed in the right direction. The thrusters are warmed up and doing their job. And now we've spun down from the 2 revolutions per minute that the vehicle had the whole way to Mars. It was a spin-stabilized spacecraft. And then from here on out, it's going to just be a bullet, and it's going to control its orientation and attitude via rockets on the back of that back shell.
Points carrier lock. DTE from Radio Science from Green Bank reports carrier lock. You see the carrier on the downlink.
Flight level 1.
We are continuing to wait for entry interface. We're about 6 minutes and 45 seconds from entry interface. We have confirmation from Greenback that they are receiving direct to Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones. These tones indicate that Perseverance is operating normally and has nothing significant to report. this is as expected. We're currently just over 6 minutes from entry interface, receiving direct to Earth telemetry via that path.
Okay, and now we wait. As soon as we get to the top of the atmosphere, it'll be very quickly, which is the entry point. It won't be very long before the atmosphere will start getting thicker and thicker. It's going very quickly at a fairly steep angle of 15 degrees into the atmosphere, and as it starts to slow down.
We're just under, we're about 5.5 minutes from entry interface. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
Okay, let me just butt in again. We're still a few minutes away, so the action is starting about 4 minutes from now. I just wanted to quickly mention that I think I have found a way to catch up with at least the Facebook comments down here. So just a quick hi to everyone. Whole bunch of you calling in from places all over the world, which is really nice to see. Certainly a big tēnā koutou to everyone in New Zealand and all our UK people. Those of you who were part of our brownies session this morning that have stayed in to watch. Nice to see you guys and everyone else. I will be around afterwards. Remember to catch up with you guys, and hopefully we will be able to actually chat a little bit more for those of you who want to hang around for that. So let's get back and see what's happening at NASA.
That's what he said, but to land safely, but we really need it for our own health and well-being today to keep our nerves under control. But
around this time, a second spacecraft, Maven, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're currently at about 3 minutes until entry interface.
Okay. Very soon we'll be getting ones and zeros, I hope, from our radio on the rover. The entry interface is nothing more than just an arbitrary place in the sky that we've defined to be above the atmosphere. But from that point on, there's definitely atmosphere, and above it there isn't.
We are 2 minutes from entry interface. Perseverance is to transmit heartbeat tones, indicating everything is nominal.
So the tones can tell us whether something's bad or not is happening. So far the heartbeat is doing well. So the vehicle thinks it's in good shape to land, which is a great sign.
We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second. We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry. We are 1 minute from entry interface.
Righto, this is it, Space Cadets. This is it. You ready for this? I don't know if I'm ready or not. I can't deal with this.
MROs are in receive mode.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Confirm your jet data flow.
About seconds from entry interface. 5.3 kilometers per second and an altitude of about 150 kilometers from the surface of Mars. We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars.
Look, just quickly, if you're not sure what's happening here, we are seeing a live CGI representation of what's happening. So this is based on actual data, but it's not real video. It's a computer-generated view of what is actually going on, based on real data.
Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
Tristan, yes, what we are seeing has actually, this has already happened. One way or another, it's already happened. We are just seeing the delayed version because it takes about 11 minutes for the information to get back to us.
The vehicle should be doing its turns right now.
MRO has lost lock.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Yes, 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 yes.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target. Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, but to the target on Mars, but instead is flying straight to the target.
Parachute.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO's reporting good telemetry log.
We are coming upon the straighten up We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Yes, yes, yes.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
That's really good news. The parachute deployment is where there's a lot of risk, so that's very good news.
Yes.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes, yes, yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers of the surface. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Almost there.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Yes.
We have priming of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
This is it.
We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
That's okay. That doesn't matter.
As expected.
Sky crane maneuver has started. About 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Oh my God. Oh. Oh.
MRO reports they're still getting telemetry from the lander.
All right, all stations.
We got it. We're
Touchdown
there.
confirmed. We're going to wait for the images.
Wow.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
That'd be great.
So much. much has been riding on this.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
It's not
Flight, we have seen the completion of EDL 3000.
Copy activity. That is as expected.
So we're down, obviously. We're happy, obviously. It's all looking really good.
Seeing a strong signal from the lander.
Still getting telemetry, it's all sounding good. And we're just standing by for the first image. Now remember, we're not expecting too much from the first image. It may not come through quickly. We are hoping that it will be through within a minute or two.
We've just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in.
That's it.
Looks like we're getting the first image.
That's it.
Here, take a look at the first image.
Flight, this is OL3. I have the target point on the map when you are ready.
We are ready, OL3. Go for it.
Flight, I'll be moving in, showing you the safe zone that we've landed in.
Incredible, they're going to show us. Oh, look at this! Oh, it's so beautiful! Oh.
The team has just put the first image from Perseverance on the surface of Mars. Now, it comes from the engineering cameras, known as the hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
Look at that, right? You get the safe.
Let's see our engine. Nice. This is amazing.
That's better than I was expecting. That's amazing. I was actually thinking there would be a cover still on it and we'd see some debris and everything, but it's quite a nice view. As they said, this is from an engineering camera. It's not about the image quality so much just yet. So we're down. They're going to show us apparently where they've actually landed so we can see how well they targeted it. It looks like they've landed pretty well, but hopefully we will see exactly where they've landed shortly.
You did it. You did it. You did. You led the team. You made it happen. Congratulations.
We just got our second image in. Our second image is in.
Ooh, let's have a look at that.
These we have a camera in the front and out rear of the spacecraft. They're near the ground, so these are pretty close. So you can see the wheels there, and they're a little dirty because we've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago. Just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. This is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country on all of the problems we have. We need to work together to do these kinds of things and make success happen.
Ooh, there's people touching each other.
Joining
That's
us
not very
now
social distancing.
is the acting administrator of NASA, Steve Jurczyk. Steve, welcome and congratulations.
Hey, thank you. What an amazing day.
How does it feel to have another rover on Mars?
It's amazing. to have Perseverance join Curiosity on Mars, and just a credit to the team. I mean, just what an amazing team to work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID, and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every time we execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters. This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission, but if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions. And then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars. And then for human exploration, we have the Mars Entry, Descent, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment in our laboratories here on Earth.
Now, I hate to be rude, but I'm actually just going to cut them off there because we have already covered a fair bit of that kind of stuff. I'm keeping an eye on it, and as soon as there is anything interesting to update, any more images or an exact landing spot, we'll cut back to it. But I just wanted to quickly catch up and say thanks again for everyone for joining. I am happy to hang around and keep chatting. I've kind of got your comments here. They're not updating properly. It's, as you guys know, it's an ongoing issue trying to keep an eye on comments and stuff as we keep going. But thanks everyone for joining us from all around the world. I see we ended up getting quite a few of you from the UK joining in. Thanks so much for to all the scout groups and schools over there who have shared this around in the UK and decided to join us in New Zealand to watch this. It's really nice to have you on board. Let me see if I can just quickly whiz through at least some of the Facebook comments that I've got here. Lots of people commenting on just how cool the whole thing is. Hi Karen in the UK, nice to see you. We'll be catching up with you again soon. I've actually got something to show you, Karen. Don't let me forget when about your badge that you sent me. I'll show you when we have our next session. Thanks everyone who's saying nice comments about the coverage. What else is everyone saying here? Yes, we did cover that question about whether what we were seeing was delayed. So it was all delayed about 11 minutes. So we were kind of watching it as if it's live, but it had actually already happened by the time that we were seeing it. Looks like on NASA they're just sort of getting a few comments from people about things that we have already talked about. So I'll just keep an eye on that. Lots of wow, this is fantastic and everything. Andrew's saying it looks you had a couple of dodgy moments on the way in. Pleased it landed okay. I think it actually all went pretty well though. I don't think there was anything too dodgy on the way, and a couple of things that were expected when we lose the telemetry and stuff. But that's all fine. We do expect that. Shout out to the First Whittington BP Scout Group. Thanks guys for joining in. Lovely to see you guys again. Everyone's saying it's exciting. It sure is, isn't it? Well, I was tearing up a little bit there. Yeah, when it happened. And you can see the guys on the ground in mission control there. You can see their eyes sort of tearing up a little bit. What else we got over here? Debbie, hi Debbie. Yeah, looking forward to our session with you guys as well. Right, Hannah and you guys from the Brownies this morning. So I was talking to the Brownies in the UK this morning before we had our session here. We had a lovely session with a group of Very intelligent brownies, actually. It was awesome, that session we had with you guys this morning, and thank you for staying up. It was a bit late for the brownies over there. It was, it must have been about 9 o'clock or something by the time touchdown happened, so good on you guys for sticking with it. The Griffin Cubs in the UK, you've joined us as well. Goosebumps from Melanie, absolutely. Oh, it's tingly stuff, isn't it? Oh, let's just see what's happening on NASA. Have we got any more images coming from here? Let's hear.
Hi, my name is...
No, we just, they've been doing a bit of this, just showing videos from people around the world, which is all very nice. But I'll just keep an eye on it. So, look, if anyone has got any other... I'm having trouble with the YouTube comments. I just can't actually really see them from where I am right now. Sorry about that. For some reason, our YouTube widget just hasn't kicked in at all. Let me just reload my Facebook page and see if we've got anything else. Oh, Michael, nice to see you, Michael. Thanks again. Oh, yeah, you guys from the Cubs, of course. Right, let me just see if there's anything updated over here. I don't think it has updated for me. So, righto, who else have we got on Facebook? Right, basically lots of people just echoing the sentiments that it's all very exciting. It is so cool. So what, a few people are asking about when we get to see some of the better images and stuff. That won't come for a while. So yeah, we just have to be very patient. It will at least be a few hours before we start getting any of the really good stuff. So there's a few issues here. Basically, to get the information from the rover back to Earth, there's a few different ways they can do it. It has a very limited capability of sending stuff from the rover directly back to Earth, but that's very low bandwidth. And it's not great. And of course, once it gets around the, so it can't see the Earth anymore, it can't do that. What it is really relying on is other orbiters. Actually, I wonder if I've got any of them here that are, so robotic orbiters that are around Mars that can relay the information back. Oh, that's not very good. I mean, I can't find those images easily. But anyway, so what it's got to do is wait until it can upload some images to one of the other orbiters, and then they can transmit it back to Earth. So it sort of has to wait until they come around and they're in a good position. So the images will take at least a few hours before we start getting any of the good images. Keep an eye out on the news. It'll be all over the news, hopefully. It should be. Then other things that we need to wait for, the awesome Ingenuity helicopter that we were looking at earlier on. Oh no, this isn't the helicopter, sorry, this is the sample. Well, let's talk about that. This is taking the samples. That's not going to happen for some time. It'll actually need, the rover will need to move somewhere else. They'll need to pick a sample site. And of course, these samples, remember, are actually going to be picked up by a later mission. So this is actually years in the future when we retrieve these samples. The helicopter, let's go and have a quick look at the helicopter. This is what we were looking at before, the Ingenuity. I believe it's going to be a few weeks before this actually happens. So everything on these videos is very much sped up and makes it look like it's happening very quickly, but it's not. It takes a long period of time. So sometime in the weeks ahead, we will see something from the helicopter. I'm really looking forward to this. This is the first powered flight on another planet. It's pretty exciting stuff. So I'm not sure that there is much really happening on NASA. They really are just sort of chatting to a few people about things that we've already talked about. I was hoping that we might get a closer map of where we've actually landed, which would be a nice way to finish off this coverage. Let's just have a listen and see what they are saying.
To make them safe for the employees. It's just an incredible amount of work by the entire lab, and of course, especially by this team. And you know, and in one sense, you know, the 7 minutes of terror are very exciting. But on the other hand, you know, the mission's just started, right? We built the mission, you know, not to land, but actually to drive and get the samples and do other technology, you know, demonstrations. And so, you know, for much of the team, you know, this part of the mission's over, but for most of the team, the mission's really just starting. And so, you know, I think they're very excited, but, you know, everybody, I think, can take a deep breath and a sigh of relief now that we are safely down on the surface.
Yes, that collective sigh of relief, and I hear a lot of excitement and celebration behind me as well. So thanks so much for joining me, Mike.
It's my pleasure, and thanks to everyone for joining us too.
Congrats again to the Mars 2020 Perseverance team for a successful landing. Back to you, Raquel.
Now, there will be a flight test coming up for the Ingenuity Mars helicopter, and if this technology experiment is successful, it would mark the first time we have taken a power-controlled flight.
Okay, we've already talked about all that sort of stuff, so I think most likely that's just what they're going to be doing now, is just chatting about things. So I actually think that is probably about where we might leave it. What I'm going to do is, just before I do that, I'm just going to try and reload my Facebook comments again. Now, my sincere apologies to our YouTube viewers. YouTube is normally the one that goes much better, but I just wasn't organised enough, to be honest, this morning. I will have to try and catch up with your comments afterwards, so sorry about that. Let's just have one last look through our Facebook comments. I can't believe how many of our scouts from around the world we've had come in and join us for this. This has been really cool. Hi, Wendy. Nice to see you again here. We'll catch up with you again sometime, hopefully soon, where I am honestly going to have a telescope session. I haven't forgotten about you guys. By the way, if anyone else is wondering about our telescopes, I'm getting lots of questions about when we're getting more telescopes back in. We are expecting our next shipment later this month or early March. Daniel's asking, when did Perseverance leave Earth? So that was back in July 30th, 2020. So this, if you missed it earlier on in the coverage, this was Perseverance leaving Earth last year in July. So it's been traveling since then. This is when it started its journey. Rebecca is asking, Dave, will there be a recording of this post live so that Newland Scouts can watch at their next meeting? Absolutely. If you go to spacecentre.nz/live and click on our YouTube channel, it will be archived there along with all our other stuff. So just go and check that out. I think, is that all the comments? Yep, I think that is all the comments that we have had on Facebook. I wonder, I'll tell you what I'm going to do. I am just going to see if I can quickly catch up with our YouTube comments, because I think I might... Oh, no, it's not showing me them. Why not? Okay. It was worth a try. Okay. Oh, hang on. I'm looking at the wrong video. Let's try this one. Okay. All right, we've got a whole bunch, by the looks of it, of YouTube comments. Let me see if I can just quickly whiz through those. Sorry, guys. Ian, nice to see you. Glenn, hi. It's going to take me a bit long to get through all of these comments. I might have to catch up with them all afterwards, but thank you very much, everyone, for what you are saying there. Casey, nice to see you again. Thanks, guys. Vivian, TJ, Daniel over here. Awesome. Okay, look, I will try and get into YouTube after this and catch up with some of the comments there. But I think we might leave it there, because I think all the important stuff has happened. So keep an eye on the news. Hopefully we'll see lots of this. Images to come in the next few hours, and more juicy scientific results in the weeks and months and years ahead. So the normal mission would be expected to go for at least the next 2 Earth years, or roughly 1 Mars year. But hopefully we'll have an extended mission that should go much longer than that. So thank you so much, everyone, for joining me today for a very exciting time. It's been absolutely fantastic. And all the best, everyone. Ka kite anō, stay safe, and we will catch up again with you all very soon. So thanks, everyone. Let me just get myself... I'll tell you what, we should leave on a picture of the rover, if I can just go back to where we were. Let's finish on this picture. This is a beautiful picture. So see you, everyone. Bye-bye.